Hi, welcome to today's video. Today we're going to be talking about dividing square roots. So let's just talk about a little bit about what that means. Um, when we are dividing square roots, what that really means is we're going to rationalize the denominator. So rationalizing the denominator is simply the process of multiplying the top and bottom of a fraction by the same radical that is in the denominator. Okay, so if you think about that, if it's the same on the top and the bottom, really what we're doing is we're multiplying by one in disguise. Um, so we'll see some examples of that here in just a second. So first, let's review some of our radical rules. We talked about some of these in a previous video. In our first radical rule, the square root of AB is equal to the square root of A times the square root of B, which is equal to the square root of A times the square root of B. Rule number two, if we add two fractions with the same radical, we just add the coefficients. So the square root of x times the square root of a plus y times the square root of a. We'll notice the square root of a is the same, so we simply add x and y together, keep the same square root, just like what we would do if we were adding with like variables, like 3x plus 4x is equal to 7x. Okay, and our third rule is the square root of a squared is equal to the square root of a quantity squared, which is equal to just a. And if we think about what the square root is, we're thinking about what number times itself is equal to what's underneath the radical. So in this case, if it's a times a, when we take the square root of it, we just get a. They kind of cancel each other out, basically. So now for our new rules for today. The square root of a divided by b is the same as the square root of a divided by the square root of b. And this rule has to do with what we just talked about up here, rationalizing the denominator. The square root of a divided by the square root of b, if we want to get rid of the radical down here, we multiply top and bottom by the square root of b. So in this case, we get square root of ab divided by the square root of b squared, which the square root of b squared, just like what we talked about up here, is just b. So we get the square root of ab divided by b. Okay, so one question that often comes up when we're doing this is, why do we need to do this? What is the importance of learning this? Really, the roots of this go back to days before we had calculators to do a lot of these calculations. So it's not as important to do this in today's world with calculators, but it's still an important skill to kind of learn. Here is why. If we were adding these two fractions, the square root of 2 over the square root of 5 plus the square root of 3 over the square root of 6. If I were to just look at that, I would not know what to do without a calculator. I wouldn't be able to even estimate that in my brain. It really looks kind of difficult to add together. But if we rationalize the denominator, we get the square root of 10 over 5 plus the square root of 18 over 6. Okay, so if I were to just, in my mind, try to estimate that, I know that the square root of 10 is just a little bigger than 3. And 3 over 5 is about 0.6. The square root of 18, well, the square root of 16 is 4, so square root of 18 is just a little bigger than 4. So 4 over 6 is 2/3. So, and this is a little bit bigger than 4, so I'm going to say this is about 0.7. So 0.6 plus 0.7 is 1.3. When I used a calculator to actually find what this was, I found that it was about 1.34. So to be able to estimate that and be within 400ths is pretty close, and usually if we didn't have a calculator to find that precise exact number, probably being within 400ths of the correct answer is definitely close enough. So that really is why rationalizing the denominator is kind of an important skill to know how to do, just as far as estimating what something like this might be. Okay, so moving on. Let's do some examples here. We're just going to have a few examples today. We're going to start out with an easier one. So we start out with the square root of 12 over the square root of 75. So remember, when we have two radicals divided, we can write them as a single radical with a fraction underneath. So we can rewrite that as the square root of 12 over 75. Now that happens to be a number that we can reduce. So if we divide top and bottom by 3, we get 4 over 25. And the nice thing about those two numbers is they're both perfect squares. So the square root of 4 happens to be 2. The square root of 25 happens to be 5. So we can reduce that fraction to 2/5. So this down to this looks a lot more easier to work with. Okay, second one, square root of 10 divided by the square root of 45. Again, I'm going to rewrite it as a single radical. So 10 over 45, and we're taking the square root of that. So notice in 10 and 45, they both have a factor of 5. So if we divide top and bottom by 5, 10 divided by 5 is 2, 45 divided by 5 is 9. And now when we split it back out into the two separate square roots, square root of 2 over square root of 9, 9 happens to be a nice perfect square. It's 3. So we have the square root of 2 over 3. And really, the square root of 2 is about 1.4. So 1.4 over 3 is just a little less than 1/2. So again, if we wanted to estimate what this was as a decimal, without having two radicals in here, it's a lot easier to work with. Okay, so next one, we're going to get a little more complicated here. The square root of 42 over the square root of 66. So once again, I'm going to rewrite it as a single radical. 42 over 66 underneath the square root symbol. Okay, so notice here we do have a common factor. They both have a factor of 6 in them. So if we divide top and bottom by 6, 42 divided by 6 is 7. 66 divided by 6 is 11. So we have 77 over 11 underneath the radical. So now let's split that up into two radicals, square root of 7 over square root of 11. And remember, rationalizing the denominator is the process of multiplying the top and bottom of a fraction by what we have in the denominator here. So we're going to multiply top and bottom by the square root of 11. Okay, this is rationalizing the denominator right here. And again, note, square root of 11 divided by square root of 11 is 1. So really, we're multiplying by 1. We're not changing the fraction at all. We're just changing how it looks. Okay, so when we multiply 7 times 11, we get 77, and that's still underneath the radical, so square root of 77. When we multiply square root of 11 times square root of 11, remember that's square root of 11 squared. So the squared and the square root cancel each other out and leave us with just 11. So we have the square root of 77 over 11. Okay, so next one, again, getting a little more complex. 5 plus root 3 over 4 root 14. So again, first thing you might want to think about is there some way we can reduce this particular radical? Well, the square root of 14 is not one that we can reduce any further. So we're going to multiply top and bottom by the square root of 14. So we're rationalizing the denominator once again right here. Again, remember 14, square root of 14 divided by square root of 14 is just 1. So we're not changing the fraction, we're just changing how it looks. Okay, so on top, one thing you have to keep in mind is, since this is 5 plus root 3, we have to multiply this by this term and this term. So we have to use the distributive property. So we have 5 times the square root of 14 plus the square root of 3 times the square root of 14. So I just distributed the square root of 14 to both terms. Okay, on the bottom we have 4 times the square root of 14 times the square root of 14 again. Okay, so let's take a look at the bottom. The square root of 14 times the square root of 14 is 14. So 14 times 4, well, 14 times 2 is 28, times 2 again is 56. On top, 5 times the square root of 14, we can't simplify that one, but here we can simplify this. 3 times 14 is 42, so we have 5 square root of 14 plus the square root of 42 divided by 56. Okay, and this is, we have simplified this into this. I realize, and this is kind of the case where when you look at it, it doesn't really look like it's simplified, This is actually the simplified form of this. And again, with a calculator, it would be just as easy to calculate what this is as it would be to calculate what this is. So sometimes rationalizing the denominator isn't necessarily helpful, but that is the process. So this is, when it says to simplify, this is what we're looking for. Okay, last example. Negative 1 minus 3 root 2 divided by 2 root 8. Okay, so let's take a look at the denominator. The square root of 8 there, we can simplify a little bit because 8 is 4 times 2, and of course the square root of 4 is 2. So on the bottom, we have 2 times the square root of 2. Okay, on top, we just have negative 1 minus 3 root 2. So now we get into rationalizing the denominator once again. So we want to get rid of this square root of 2 out of the denominator. So we're going to multiply top and bottom by that radical, square root of 2. Okay, again, up here notice the square root of 2 divided by the square root of 2 right here. It might be tempting for a lot of you to just cancel that out and say negative 1 minus 3 is negative 4 over positive 4, so it would be negative 1. But unfortunately, because of this negative sign, this is two different terms, and so we cannot just cancel those two out. That doesn't work. So if we would need another square root of 2 here, and we would have to cancel a square root of 2 from this and this. But since 1 is not present here, we can't do that. Okay, so let's rationalize the denominator, multiply by square root of 2 over square root of 2. Again, we have to distribute on top here. So we're going to multiply square root of 2 times negative 1 and square root of 2 times negative 3 root 2. So I've shown that right here. When we multiply square root of 2 times square root of 2, I went ahead and showed them both underneath the one radical. I just used that property or that rule from earlier that we talked about. Okay, and on the bottom we have 4 times the square root of 2 times 2 once again. So let's talk about the denominator. Square root of 2 times 2 we know is just 2. So on the bottom we have 4 times 2, which is 8. On top we have negative root 2. I just multiplied those together. So negative root 2 minus, and again here 2 times 2 is 4, square root of 4 is 2. So we have negative 3 times 2, which is negative 6. So we have negative root 2 minus 6 over 8. Okay, once again, it might be tempting to try to reduce these or say, well, we have a 2 here, so let's reduce a 2 and divide this by 2 and divide this by 2, and everything simplifies. But since this 2 is under the radical, we don't have a common factor of 2 in all three of these terms, so we cannot do any canceling. This is as reduced as it will go. So please be careful when you're dealing with these. Don't just randomly cancel things unless you know for sure there's a factor in every term that you can cancel out. Okay, so that's all we have on rationalizing the denominator. I hope you enjoyed the video. Have a great day.